So in this video, we're going to talk about the problems that are in the Unit 4 test review. So in this first question, it wants us to write this problem in logarithmic form. Remember that we have this property if we have the log base b of a equals x. Remember that we can rewrite this in exponential form as b to the x equals a. So we're going to have to do a little bit of backwards thinking in this problem. Instead of going from log to exponential, we're going from exponential to log. Well, remember the nice thing is that the base of the exponential equation is going to be the base of the log. So we have to think like with our arrows, right? So this is going to be like 5 to the whatever over here is going to be the exponent. So the 3 is going to go here and then that equals, right? So my arrow comes back. So that's going to be 2x minus 1. Okay, so if we write this in exponential form, it's going to be the log base 5 of 2x minus 1 equals 3. Okay, so now let's try number 2. It says, what is the approximate value of x? So in this problem, we need to work on getting that variable by itself, right? So we're going to isolate the term with a variable, and it's already isolated. Well, now we need to get that variable down out of the numerator, out of the exponent. So what I'm going to do is I'm going to take the common or natural log of both sides. Either one, it doesn't matter, because you just want to do common or natural log because that's going to allow you to use the calculator to solve. So I'm just going to do the common log of both sides. And what I can do is with a power property, I can bring this 3x down in front. Okay, so I have 3x log of 13 equals the log of 56. Okay, so now here I have an x that's being multiplied by 3 and by log of 13, right? So this is basically the same thing as x times 3 log 13. All I did is I put all those constant terms together. And so what I can do now is divide both sides by 3 log 13, and that's going to allow me to get that x by itself. So what I'm going to do now is I'm going to divide both sides by 3 log 13, so this is all going to cancel. So I have x equals log of 56 divided by 3 log 13. So if it was asking for an exact answer, I would leave this like this. Since it wants me to approximate, I'm going to go ahead and do this in my calculator and get a decimal value. Okay, so I'm going to do log 56, enter, divided by, and then I need to put that denominator in parentheses. Okay, so I'm going to do parentheses 3 log 13. Okay, and then close parentheses and hit enter. And so that gives us the approximate value of x. Okay, so what I did is put all of that in parentheses. So I have 0.5231. Okay, that is the approximate value of x. All right, so in this problem it says that suppose you deposit $7,000 into a bank account that pays 2% annual interest compounded continuously. Assuming that you make no other deposits or withdrawals, how long will it take before your account balance reaches $10,000? Okay, anytime we have compounding continuously, we need this formula, A equals PE to the RT. Okay, so now let's think about what we have. So we have $7,000. Okay, that is the starting value in our account. So that is going to be the value of P. Okay, that's going to be the principal. And then we have E, okay, and then it tells us 2% annual interest compounded continuously. So that means R equals 2%. So I'm going to convert this to a decimal by moving it 2 places to the left. Okay, so R equals 0.02, and so we have 0.02, and then we have T. T is going to remain as a variable because that is what we're trying to figure out, right? So how long means what is T? And then it says before your account balance reaches $10,000. So that's like the end goal, right? So that's going to be the value of A. So what we're going to do now is we're going to work on solving this exponential equation. So what we can do is work on getting that term with a variable by itself. So we're going to start off by dividing both sides by 7,000. Okay, so when we do that, we have 10,000 divided by 7,000. And so that gives me about 1.42857. Okay, and that equals, here the 7,000s cancel and we have e to the 0.02 times t. Well, now to get rid of that e and to bring this variable down, I'm going to take the natural log of both sides, right? Because the natural log is the opposite of e to some power. So I'm going to do the natural log of the left side and the natural log of the right side. And what I can do now on the right is I can bring this power down in front. Okay, so I have the natural log of 1.42857 equals 0.02 times the natural log of e. Well, the natural log of e, that's just like taking the natural log of the base, right? So that's going to cancel itself out, and that's just going to be 1, okay? So now I have 0.02t times the natural log of e on the right side. And so now to solve for t, I'm just going to divide both sides by 0.02. Okay, so I'm going to divide the left and the right by 0.02. So all I'm left with on the right is t. Okay, because this is going to cancel and I have t. And then to find the value on the left side, I'm going to do the natural log of 1.42857 and then hit enter and then divide by 0.02. So when I do that, it gives me about 17.8 equals t, and I can round that to about 18 years. Okay, so that's how you would figure out how long it'll take your account balance to reach $10,000. Okay, so let's try number 4. It says to rewrite this logarithmic equation in exponential form. So remember, this is where we can draw those arrows and use that to help us out. So in exponential form, this is going to be 3 to the 4th equals 81. All right, let's try number 5. It says to evaluate this logarithm using your calculator. So this is the natural log. So what you're going to do is you're going to click natural log and type 375 and hit enter. And it gives us the value, right? And so we're going to round this to 4 decimal places. So we have 5.9269. Okay, and that is the value of the natural log of 375. All right, let's try number 6. It says to solve this equation for y. So notice this is a logarithmic equation. So what we're going to do is we're going to rewrite this in exponential form. Okay, so when I rewrite this in exponential form, this tells me that 7 to the y equals 343. Well, now this is like those exponential equations we were solving back in unit, or earlier in the unit, right? So we want to have both sides have the same base. So like this is one of those things where my goal was to turn this into a to the x equals a to the y. So on the left side, I have a base of 7. So if I can rewrite the 343 as a power of 7, that would really help me out. Well, notice that 7 to the 3rd is 343. So I can write this as 7 to the y equals 7 to the 3. So since I have the same base now, I can set the exponents equal to each other. So that tells me that y equals 3. All right, so in this problem, it says, what is the value of x? And it gives me an exponential equation. So when I'm solving this problem, I want to get that term with a variable by itself. Well, it's not by itself because it's being multiplied by 5. So what I'm going to do is I'm going to actually divide both sides by 5 so I can get that exponential term by itself. So here the 5's cancel and I have 7 to the 2x equals, and then on the right side I have 230 divided by 5. So when I do that, that gives me 46. So I have 7 to the 2x equals 46. So now I need to get that variable out of the exponent. So what I'm going to do is I'm going to take the common log of both sides. So I'm going to do log of 7 to the 2x equals the log of 46. So now by the power property, I can go ahead and bring this 2x down in front. So that gives me 2x log of 7 equals the log of 46. Well, notice that here I have an x that's being multiplied by 2 and by the log of 7, right? So this is basically like x times 2 times log of 7. So in order to solve for x, what I can do is I can actually divide both sides by 2 log 7, right? Because that's going to leave the x alone because it's going to cancel everything else out on my left side, right? So the 2's cancel and the logs cancel. So since it's asking me for an exact value, I'm just going to leave this as is. So I'm going to say my answer is x equals the log of 46 divided by 2 log 7. Okay, I don't need to plug it into my calculator and get a decimal because this is actually asking me for the exact value. Okay, so now let's do number 8. In number 8, it gives us a logarithmic equation and it's asking what transformations have been performed on the graph of f of x equals the log of x to get the graph of g of x equals 5 times the log of x plus 7. Okay, so what we need to do is we need to use this from our study guide and compare it to what we have to figure out what changed. So if we have g of x equals 5 log x plus 7, okay, notice there's a 5 right there that's being added in. and we also have a plus 7. So what are these going to do to our function? Well, notice that this 5 is a value of a. Okay, our study guide tells us that if a is bigger than 1, right, the absolute value of a is bigger than 1, that is going to be a vertical stretch. Okay, so that's what's going to happen to this graph. So I can go to my answer choices and I can say, well, I know there's a vertical stretch. Well, what about this plus 7? The plus 7 is a value of k. All right, so it tells me that it goes up when k is bigger than 0. So that means it's going to go up 7 units. So this graph is also going to be translated up. Okay, so there are two transformations, and remember, if you always want to double check, you can always go to Desmos and type log of 7, and then enter the transformed function, 5 log of x plus 7. And then notice that if you look at the graph, you can see that it is vertically stretched, right? You can see it's vertically stretched by a factor of 5, and you can see that it's also been translated up 7 units, right? See how this graph has been moved up like that. Okay, so remember, you can always use Desmos to verify your transformations once you've identified them on your own. Okay, so now let's try this problem. So this problem tells us to solve this logarithmic equation. Notice since I have two terms over here, I'm going to combine them. And so I'm going to use the properties to combine them. Remember, we can use the quotient property. So the quotient property tells us that when we're subtracting, we can combine these by division. So I will turn this into the log base 2 of 2x over x minus 3 equals 3. Okay, so now in order to solve this, I can actually turn this into exponential form, right? So I can turn this into 2 to the 3 equals 2x over x minus 3. Well, 2 to the 3 is 8, so this turns into 8 equals 2x over x minus 3. And just to make it a little bit easier when we're solving, I'm just going to flip this equation around. I'm going to write this as 2x over x minus 3 equals 8. Okay, you don't have to do that, but I just did that because the way we are going to solve is we are going to crisscross multiply, right? So I'm going to multiply like this. So I get 8 times x minus 3 equals, and on the right side I have 2x times 1, which is just 2x. So on the left side I need to distribute that 8, so I'm going to get 8x minus 24 equals 2x. So now what I need to do is I need to solve for x, so I'm going to gather all my variables on one side. So this 8x over here is a positive 8x, so I'm actually going to subtract 8x from both sides. And when I do that, I get 8x minus 8x, which cancels, and I have negative 24 equals 2x minus 8x, which is negative 6x. So now I'm going to divide both sides by negative 6, and negative 24 divided by negative 6 is 4, so that gives me 4 equals x. And that is the solution to this equation. Okay, so in this problem, it asks you which graph represents negative 3 log of x plus 5 minus 1. So what it's really a good idea to do is to graph this in Desmos, and it'll give you a good idea of what this graph is supposed to look like. So I'm going to go ahead and type that in here. So we have negative 3 log of x plus 5 minus 1. Okay, and so Desmos will give me a nice picture of what this graph is supposed to look like. So you can see it's like shaping like this, and it's like it opens in this direction. So I can already go ahead and eliminate answer choices C and B, right? Because those are opening in the wrong direction. So now it's a matter of which graph A or D matches. So some good reference points are the X and Y intercepts. And actually the nice thing about Desmos is if you click on them, it'll tell you the coordinates. So I have an x-intercept at negative 4.536. Okay, so I'm going to look for something with an x-intercept at negative 4.5360 and a y-intercept at 0, negative 3.097. Okay, so those are going to be some of my identifying features. So if I look at this graph, you can already see on D that it has a positive x-intercept. So that already looks like it's not going to work. But if we look at A, you can see it does have an x-intercept between negative 4 and negative 5. And it does have that y-intercept right there at a little below negative 3, right? So that's why A is the correct answer. So, you can use Desmos to help you out on these graphing questions.